All right, one class didn't get to do this changes in enthalpy stuff, so I will do that real fast. You can either fast forward to where I flip to the next slide or just listen again. You can see in this equation that 2 moles of H2 are reacting with 1 mole of O2, and that when they do that, they make 2 moles of H2O. Well, the truth is they don't just make 2 moles of H2O. You can see here that you see the negative means exothermic, that they're also giving off 483.6 kilojoules of energy. The energy is like a product too. And so these delta H values are going to be given to us in the problem like this. And again, this equation relates to this delta H. It's like part of the coefficients. It's part of the values. You can also see that there's a second equation here, which is just the reverse of the first equation. So instead of making H2O, we're decomposing H2O. And if you notice, the only difference in the delta H is the same number, but negative and positive. Because if it takes energy to break up the H2O, then it's going to also release energy when it makes that H2O. All right, so the math. Now, hopefully you'll agree that the math is pretty easy. It's stoichiometry. So as long as you know how to set up a stoichiometry problem, you're not going to find this probably too difficult. It's just a new conversion factor, and the conversion factor is going to involve this delta H and then the coefficient for whichever substance it is that you're using. Now, I have the steps broken down here on the paper, but I don't want to do them as 2 separate steps, actually. I want to do them all as 1 step. So if you'll do all of this under step number 2, kind of combine these 2 steps into 1 math problem, because I don't want you separating it. It makes it more difficult. So you're going to start with what you know, which is that you have 454 grams of propane, C3H8. Okay. Then for every 1 mole, I'm going to convert this into moles. That's our first step. For every 1 mole of C3H8, if you look up the molar mass for C3H8, it is 44.0 grams. C3H8. So now at this point, I've gotten my gram value into moles. Now it wants to know how much heat is evolved from that specific amount. And I know in my equation, I'm looking at propane. So for every 1 mole, see there's a 1 here, every 1 mole of propane, along with all this other stuff, is going to make negative 220 kilojoules. So I'm going to make another conversion factor. I'm going to put moles, C3H8 on bottom, and I'm going to put kilojoules on top. It's not kilojoules of C3H8, just call it kilojoules because it's the kilojoules for the whole reaction, but it's related to the mole value. So look back here at the coefficient for C3H8, there's 1 mole. So for every 1 mole of C3H8, we get negative 2,220 kilojoules. And you notice that that gets your unit to where you need it. Please do not just assume that it's always 1 mole. It's the coefficient from that substance in the problem. So if I multiply this out and then divide and round to 3 sig figs, I'm going to get negative 22,900 kilojoules. So it's stoichiometry, just with a new conversion factor. Your conversion factor here is new. You get the kilojoule part from here. You get the mole part from the coefficient for whichever substance. So if I had used O2 in this problem, I would have had a 5 there. If I had used CO2 in this problem, I would have had a 3. If I had used H2O, it would have been a 4. So it's all dependent on that coefficient. Okay, so let's try another one. So this one starts us off with 15 grams of C2H6. They give us the equation. So for every 2 moles, that reacts with 7 moles. It's going to make 4 moles of CO2 and 6 moles of H2O. And then notice it also gives off negative 2,857.3 kilojoules. So we're going to take and start with our given, which is 15.0 grams of C2H6. We're going to convert first into moles. So for every 1 mole of C2H6, we have 30 grams of C2H6. Okay, that's the part we've been used to doing. Now it's our new conversion, because I need to go from moles of C2H6 into kilojoules. The kilojoule value comes from the delta H. Notice we're using kilojoules. Q is usually in joules, but delta H is usually in kilojoules. And then the mole value comes from the coefficient in front of that substance. So 2 moles of C2H6. You can do all your multiplying and then divide, round 3 sig figs. We get negative 714 kilojoules. Okay. Then there's some other notes there down at the bottom, just kind of summarizing some of the stuff we've said. Make sure you read through those and then do the homework problems. And I will see you guys on Monday.